All right, everyone. Today's video is going to be a little bit hefty. We're going to be continuing our work with the chain rule, but today we're going to be focusing on problems that require us to apply the chain rule more than once. So there are going to be some pretty complex problems. So I'm going to continue with my habit of using colors to try to identify what these kind of outer and inner functions are. And it's going to be especially important today because, like I said, we're going to have a few layers to these problems. So with the first couple that we're going to be doing today, right, we're going to have to use the chain rule more than one time to find a derivative. So for example, if we take a look at this function over here, g of t is equal to the tangent of 5 minus the sine of 2t. There's actually a lot going in this problem. So I'm going to rewrite this and kind of color code it so we see what's going on. So the first thing I'm concerned with is my outermost function. And so that's going to be my tangent. That one's pretty easy to identify. So my outermost function is the tangent. Then if I go one layer in, I'm going to have my function 5 minus the sine. But then on my very innermost layer, my innermost function here is 2t. And so like I said, we're going to be using our chain rule more than one time in this problem. It's still going to function the same. I'm going to start from the outside and then work my way in. So my derivative, g prime of t, I'm going to start with the derivative of tangent. We know that's secant squared. And just like before, all of my insides are going to stay the same. So I still have 5 minus the sine of 2t. So now I'm going to differentiate my 5 minus sine of 2t. So when I take the derivative of this, obviously my 5, that derivative turns into 0 since that's a constant. My derivative of negative sine turns into negative cosine. And my argument still stays a 2t. And last but not least, I have to differentiate that innermost function, which is 2t, and my derivative is 2. So there's not a whole lot to do with this. I'm just going to rearrange a few of my terms. I'm going to pull out this negative and my 2 out front. So I get a derivative of negative 2 times the secant squared of 5 minus sine of 2t times cosine of 2t. So once we've decided what all our pieces are, differentiating it isn't that difficult. It's mostly just deciding how many layers we have to go in. So the next 3 examples are going to help us, again, just practice identifying what all these kind of different layers are, I guess I'll call them. So down here for number 1, the first thing I'm going to do is just write this with a rational exponent. So what we really have is negative 3x cubed plus 4, quantity squared, minus 2, and this is all to the 1/5 power. So now if I recode this, my outermost function, I can see I'm going to be using a power rule on. That's all to the 1/5. Next, if I go inside, I've got something, quantity squared minus 2. And then all the way in the inside is where I have my negative 3x cubed plus 4. So now we're ready to differentiate. And again, I work my way from the outside in. So I start with my power rule. And I'm going to have to the negative 4/5. Everything inside is going to stay the same. So I fill all of that in. So now the next thing I differentiate is my quantity squared minus 2. So here I'm going to start with my power rule. I drop my exponent down to the front. So I have 2 times everything in parentheses, negative 3x cubed plus 4. And then my constant, the derivative is just 0, so that term drops out. So now for my last piece, I'm ready to differentiate what's in blue here all the way inside. So now I have a negative 9x squared, and again, that constant, the derivative is just 0. So I'm going to do a little bit of reworking here. I'm going to take my 2 and my negative 9x squared, and I'm going to keep those in the numerator of this fraction that I'm going to create. And then down in the denominator, oops, I'm sorry, before I move on, I've still got my negative 3x cubed plus 4, which is also going to stay in the numerator. My 5 is down in the denominator, and this negative exponent I'm going to drop down to the denominator to make it positive. So that whole quantity there comes down to the denominator. Now at this point, the only thing I would probably do is multiply this 2 times my negative 9x squared. So I have negative 18x squared times negative 3x cubed plus 4 all over this quantity and the denominator. And that is our derivative. Now, for our purposes right now, we're not going to get too crazy with worrying about simplifying these. We'll do some practice in a couple of days, some multiple choice practice, to make sure we're comfortable with simplifying and matching a multiple choice answer. But for right now, we'll just do very basic simplification. Okay, my next one, again, a similar type problem. Instead of a rational exponent, we have a negative exponent. So we're going to go ahead and kind of pick out our layers here. So my outside is everything to the negative fifth. On the inside, I'll use my green again, I have this quantity to the negative fourth plus 5. And then all the way on the inside, I have my x squared plus 4. So again, here we're working from outside in. So we have our power rule, negative 5 times this quantity in parentheses. And then we're going to decrease our exponent by 1, so that's going to be to the negative 6th power. Everything in here stays the same. Should have left more room. So now I'm going to differentiate my quantity in green here. And since I kind of went over here, I'm going to drop down here. So again, I have power rules. I have times negative 4. That exponent is going to come to the negative fifth. And my plus 5 term drops out. So now I have x squared plus 4 in parentheses, and I'm ready to differentiate that. And so my derivative is going to just be 2x. So again, the last thing I'm going to do is figure out what I can simplify here. So I'm going to take this negative 5 and my negative 4 and my 2x, and I'm going to multiply those factors so that out front I'm going to have a 40x. Then I have my x squared plus 4 to the negative 4th plus 5 all to the negative 6th, and then my x squared plus 4 to the negative 5th factor. And again, for our purposes, since I'm not too worried about simplification, I want to focus on the chain rule piece of this. We'll just leave our answer as is. Okay, so on the next page, we're going to do another example. where we have to use the chain rule multiple times. And then we're going to get into a couple where we're using the product and quotient rule along with our chain rule. So number 5, I'm going to go ahead and rewrite this. Now our outside function is cosine. If I go one level in, I have sine. And then my innermost function is this 5x to the 5th. So again, I sound like a broken record, right? But the idea is that we work from the outside in. So my derivative of y with respect to x, I start with the derivative of cosine, which is negative sine. Everything inside the parentheses stays the same. Next thing I go after is my sine function here. I know the derivative of sine is cosine. And again, it's cosine just of 5x to the 5th. And then the last thing I do is multiply by the derivative of 5x to the 5th, or 25x to the 4th. So the last thing I'm going to do is just rearrange. I'm going to pull my negative 25x to the 4th out front, times the sine of 5x to the 5th, times cosine 5x to the 5th. And that is our derivative. So the next two problems we're going to focus on are putting together our chain rule with product and quotient rule. So in number 9, clearly we have two factors here, so we're going to be using our product rule. Okay, along with the chain rule. So our product rule is going to function just as it did before. So we're going to take our first factor, 3x cubed plus 1, and we're going to multiply by the derivative of our second factor. Now here's where you can see chain rule comes in. So when I go to multiply, the first thing I'm going to do is deal with this exponent of 4. So to differentiate this, I'm going to take the derivative of my outside function. So I have times 4. All of my inside stuff stays the same. My exponent becomes 3. And then I multiply by the derivative of what's inside. So I'm going to multiply by negative 8x. So there we've just taken care of the first half of our product rule. And so now we add our second factor. We take that as is, and then we multiply by the derivative of our first factor. And lucky for us, this does not involve using the chain rule. That's just 9x squared. So like I said before, at this point we're not going to worry a whole lot about doing too much simplifying. The only thing I'm going to do in my first term here is probably multiply my 4 and my negative 8x. So I have a negative 32x times 3x cubed plus 1 times negative 4x squared minus 3 cubed. And then my second term, I'm just going to leave as is. Now, there is some more simplification we could do with this problem, but again, I'm going to leave that to some practice we'll be doing in a couple of days and really looking at multiple choice type questions. For our purposes, we just want to demonstrate that we know how to handle the chain rule and the product rule together in one problem. So then for today, there's just one problem left. Probably guessed it since we did our chain rule with product rule. Now we're going to go ahead and do chain rule with the quotient rule. So here we go. Y prime is our function on the bottom, our low, 3x to the fourth minus 2. Now when we do d high, we have chain rule up top. So we're going to do times 5 times the quantity x cubed plus 4 to the fourth power. We subtract 1 from our power. And then we're going to multiply by the derivative of our inside function here, which is 3x squared. So that's our low d high minus high, x cubed plus 4 to the fifth, times the derivative of our low function. And again, this one is pretty nice because that does not involve chain rule. We get 12x cubed, and that's all over low squared. So our denominator squared. And again, here I'm just looking for any simple kind of cleanup or simplification that I can do. And so I would just probably take my 5 and my 3x squared to get 15x squared, and these other factors I would just leave as is. And then here I would leave these factors the same. And just leave my denominator squared. Again, on a multiple choice test, the answer would probably look different from this, and we will be taking a closer look at some of those in a couple days, once we're more comfortable just with working with the chain rule in conjunction with some of our other rules. So that is more than enough today, and we'll get to practice with all of this fun stuff when we're back in class.